Okay, I want to look at a couple probability problems. We didn't do a whole lot in probability, but just to make sure we're okay with this. Let's say we've got like a two-way table like this. This is how often we did express several of these like this. The following table represents the employment status and gender for the civilian labor force age 16 to 24. This is in millions. So we have 9.9 million males employed, 1.4 million males unemployed, and similar for females. So what's the probability that a randomly selected 16 to 20-year-old individual from the civilian labor force is employed? Okay, the first thing I do on these tables, if they're not already given to me, sometimes these tables give you the totaling column. You need a totaling column. So let's go ahead and total these up. So we're going to say how many people were completely employed. So 9.9 plus 9.5, 19.4. So 19.4. So there's my total column. And 1.4 plus 1 is 2.4. And then also come down this way too. So 9.9 plus 1.4. Let's see, that was 11.3. And then 9 that's an easy one, 10.5. And then you want to go ahead and add across here. So let's see, I can do it better this way. It's 21.8. So 21.8 total people were employed. So that's something you definitely want to know. So the total number of people employed is 21.8 million. So what's the probability that a randomly selected 16 to 18-year-old individual from the civilian labor force is employed? Okay, so remember the probability is the number of successful events divided by the total. So again, the probability, number of successes all over the total. Okay, so how many successes do I have? In this case, the success is being employed. I have 19.4. So part A is 19.4 divided by the total number of people who are employed, 21.8. And these are generally going to be expressed in decimals when they're like this. We'll turn it on. So 19.4 divided by 21.8. And we get about 0.89. So that's a probability. Okay. How about the next one? What's the probability that a randomly selected 16 to 24-year-old individual from the civilian labor force is male? So again, you think the number of successful outcomes, the number of males in this case. So 11.3. All over the total. The total in this case is, again, the same 21.8. And I'll let you divide that on your own. So part C, the probability that a randomly selected 16 to 24-year-old individual from the civilian labor force is employed and male. So again, think about this. So what are the number of successful outcomes here? How many are employed and male? Right, 9.9. So it's going to be 9.9 divided by the 21.8. And finally, part D, the probability a randomly selected 16 to 24-year-old individual from the civilian labor force is employed or male. Okay, so let's think about this. So if they're employed, we're going to include them. And if they're male, we're going to include them. So what are we going to include? Let me erase this right here. It's getting a little sloppy. What are we going to include? Think about it for a second. Go ahead and pause the video. See if you can get this one to come out. Okay, welcome back. I know you paused it. So male or employed. So here's our employed. I'm going to use these guys here. Wait a second. Let's use my highlighter. So male and employed and male. Okay, and so I'm just going to add those numbers up right here. and it's going to be 20.8. We could have done it a little bit easier, right? We could have done the, there's only one that is not fit in our total, so we could subtracted 1 from that. Ends up being 20.8. And so we would say for part D, 20.8 divided by my total of 21.8. And again, we should be getting decimal equivalents for each of these. Okay, let's do one more. Okay, cigar smoking. The data in the following table show the results of a national study of 137,243 U.S. men that investigated the association between cigar smoking and death from cancer. Okay, so there's our table. What is the probability that a randomly selected individual from the study who died from cancer was a former smoker? I want you to think about this for a second. So what column am I looking at? We know that these folks have died from cancer. So where am I going to be looking? I know it is somewhere in this column here. Oop, I thought I had the highlighter selected. Okay, so I know I'm looking at this column right here. I can ignore all these over here, right? Probably the randomly selected individual from the study who died from cancer. So we know the person that we're picking died from cancer. We want to know what's the probability that they were a former cigar smoker. So current former cigar smoker. So there is the number of successful outcomes divided by the total, whatever this total's up to. It's 1,014. So our answer for this first one is going to be 91 divided by 1,014, whatever that comes out to as a decimal. Okay, how about part B? What is the probability that a randomly selected individual from the study who was a former cigar smoker died from lung cancer? Okay, let's erase what we've done. See if you can do this one. Pause it, see if you can think through it. Once you do a couple of these, they're not that bad. All right, welcome back. These are actually very hard if they're not in a table. So make sure you can do these given from a table. Probably a selected individual from the study who was a former cigar smoker. So we know we're looking at what column or row. We know we're looking right here. We know that the person that we selected was a former cigar smoker. So I need to find that total. And it is 7848. I hope that stays within the screen. 7848. And so the probability that a randomly selected individual from the study who was a former cigar smoker died from cancer. So it's 91 divided by the 7848. And then whatever that is in decimal form. Okay, so I hope that helps you sort of understand the basics of probability from looking at a table.